welcome and thank you for standing by. At this time, all participants are on listen-only mode until the question and answer session. At that time, if you would like to ask a question, you may do so by pressing star, then one. Today's conference is being recorded. If you have any objections, you may disconnect at this time. Please continue to stand by. Your conference will begin in just a few moments. Once again, continue to stand by. Your conference will begin in just a few moments.
Good afternoon. Thanks for joining us for today's media teleconference on NASA's Boeing Orbital Flight Test-2. I'm Josh Finch with NASA's Office of Communications. Senior NASA and Boeing representatives are here to talk more about Starliner's uncrewed flight test to the International Space Station as a part of NASA's Commercial Crew Program, including Catherine Leaders, Associate Administrator for the Space Operations Mission Directorate at NASA Headquarters, Steve Stitch, Manager, Commercial Crew Program at NASA's Kennedy Space Center, Joe Montalbano, Manager, International Space Station Program at NASA's Johnson Space Center in Houston, Mark Nappy, Vice President and Program Manager, CST-100 Starliner for Boeing, and Dr. Michelle Parker, Vice President and Deputy General Manager at Space and Launch for Boeing. We're going to begin with opening comments from our speakers, and then after that, we'll take media questions. First, we'll go to Kathy Leaders.
So thank you all for being here. Very exciting time. You know, we're continuing to safely move through our spring mission milestones, and it's very exciting now to be talking about our second uncrewed demo of the Boeing Starliner and the ULA Atlas V. This is a really important step in our continued goal of having, two U.S. crew transportation capabilities to the ISS. And as you know, robust crew services is really important to our sustained commitment to our research, the science and technology development that we're doing on the ISS, and it's critical for us meeting our exploration goals. I'm very proud of the CCP, Boeing, and ULA team that has been carefully getting their hardware ready while also resolving the issue that had interrupted our previous flow. The team's working and through their final reviews right now and headed toward our agency level flight readiness review, which I'll be chairing on May 11th. So I know you're going to be excited to hear all the progress that the team's made. And to give the next status, I'll introduce Steve Stitch, the Commercial Crew Program Manager.
Okay. Thank you, Kathy. I'm really happy and excited to be here today. It's an exciting week for us with our flight readiness reviews coming up on Thursday and Friday, and also with Starliner making its journey over to Complex 41 and getting it back to the pad. It's very important to commercial crew to have our second transportation system up and operational to continue our assured access to ISS and also to grow the low Earth orbit economy. Super proud of the Starliner team and the NASA team over the last 8 months. It's been a hard 8 months, I would say, but very fulfilling that we've resolved the problem with the oxidizer isolation valves and we're headed on toward launch. It's going to be an exciting mission on OFT-2, testing out the rendezvous system on Starliner. Also, the NASA docking system will be used for the first time as we dock to the ISS Node 2 forward port. And also, we'll have some docked operations to test many of the Starliner systems while we're docked to the space station. So a big, important test flight on the way to our crewed flight test. Every flight like this is a flight test, and I suspect we will learn a few things on the way, and we'll continue to improve Starliner as a result of this flight. We spent 8 months doing a deep dive on the oxidizer isolation valve anomaly. We have good root cause now, and it's been to the program control board and closed out between the joint space station control board and commercial crew program board, and we'll take that to Kathy on May 11th at the FRR. So we've closed that anomaly, and it's great to have that behind us. I know Mark will talk a lot about the hardware, getting ready to go fly. The spacecraft is fueled. In the C3PF, we have the service module full of oxidizer and hydrazine, and then, of course, the Atlas V is stacked and ready to go. We're working toward a launch on May 19th at 6:54 p.m. Eastern Time, and we'll have a backup on May 20th at 6:07 p.m. Eastern Time. Again, I'm very grateful to the NASA and Boeing team. They've done a great job over the last 8 months getting this work to completion. The astronauts on board, when we talked to them prior to launch, the crew 4 astronauts, Chell, Bob, Hines, Jessica, and Samantha, they're excited to see Starliner arrive very soon. And then just a little bit of a Crew 3 status. We are working toward an undock at 1:05 a.m. Eastern Time on May 5th, with a landing for Crew 3 on as early as May 6th at about 12:37 Eastern Time off the coast of Florida. The vehicle on orbit's doing well. We've inspected the thermal protection system on Dragon. We've checked out the suits, the displays, and the ECLS system. Tomorrow we'll check out the comm systems and the guidance navigation control systems and the prop systems on Dragon. We'll have a weather brief tonight about 24 hours prior to the undock time frame, and we'll take a look at the weather and see if we continue to press forward. And that's all I had. And with that, I'll turn it over to my good friend, Joel Montalbano.
Hey, thank you, Steve, and thank you, everyone, for joining us for this mission overview briefing. Since we last talked, we've been focusing on board with the handover between the Crew 4 and the Crew 3, and that's going well. I've talked to the Crew 4 commander a number of times, and they are ready to take the helm as soon as we can find some good weather to bring the Crew 3 vehicle home. Last week, two of our cosmonauts also performed a Russian spacewalk to continue our outfitting on the multi-purpose laboratory module and MLM that was delivered last year, and that has gone well, and so we're happy to continue moving forward with activities. You know, as we look forward to the launch of the Boeing OFT-2 mission and the docking, I can tell you Space Station team is ready to support, and we're excited to have another vehicle on board the International Space Station. This mission is a major stepping stone for Boeing and NASA as we enable, like I said, an additional crew provider to the International Space Station, and we consider this a landmark flight. The crew on board will be monitoring the approach, and we'll be able to send commands to the spacecraft if needed. Going uphill, this vehicle will be carrying about 500 pounds of cargo and returning with about 600 pounds of cargo. Steve mentioned the launch time was 6:54 p.m. on the Eastern Time on May 19th. After this vehicle undocks, the team will turn their focus to the SpaceX cargo mission currently targeted for a launch on June 7th. So with that, a huge thanks to the Boeing team, the Commercial Crew Program, and all my ISS colleagues as we continue focused and look forward to this mission on board the International Space Station. With that, let me hand it over to Mark.
Thanks, Joel. First, it's a pleasure to be part of the Commercial Crew Program. And since I've been on board, I've been able to witness how everything has been coming together for flight. And I'd like to thank NASA for the partnering that has taken place over the last 8 months to work the solution since OFT's first attempt and to get us where we are today. This was a really fantastic example of how NASA and industry work together in the best interest of our space program. It's really impressive to be part of. As far as the vehicle status goes, we're doing our final preps today. Those will continue through the night, and we'll be in a position to do a crew briefing at about 0400 or about 4:15 in the morning with the crew to begin movement at about 4:45. So we're in good shape to roll the vehicle over to the launch complex, and we expect to see the vehicle over there about an hour after we roll. The vehicle status, from the standpoint of what we've done for the last 8 months or so, there's been a series of integrated systems testing on the crew module that has built more confidence that it's ready for its operation, and it's got the highest probability of successful launch. So the testing is complete and all passed. The service module, obviously we have a new service module, SM4. It's also gone through the normal build-up processes and testing, and we have high confidence that that vehicle is ready for launch as well. Once those two are completed independently or individually, then we stack those vehicles, the crew module and the service module. They again go through pre-rollout procedures and integrated testing. That's all been completed and good results from that. So over and above all of the normal work that we do to get the vehicle ready, the service module was also outfitted with a series of mitigations to alleviate the repeat of the oxidizer or valve issue. So we have a new service module, we have new valves, we have a new load of propellant, and then additionally, the system has been environmentally enclosed and purged with GN2 to make sure that there's no moisture that gets into the system, which we know is the root cause of the first launch attempt failure. The team consisting of NASA, our suppliers, and Boeing have worked very cooperatively to get to this point and conclusively prove that we have isolated the cause and we have the right preventative actions to prevent reoccurrence. Michelle Parker will speak in more details, but there's been a significant amount of testing and root cause analysis that's been performed by the entire team, our suppliers, Boeing and NASA, and we're confident that we have the right mitigation in place. We've also cycled the valves several times. We'll continue to cycle the valves until we get to launch day to boost the confidence that we have a system that's working. Very proud to be able to represent this team. We've learned a lot in the last 8 months. I've learned a lot since joining the program, and we're ready to take the next steps. Michelle Parker was the Chief Engineer for Space and Launch during this period of the troubleshooting and the testing and has a great deal of knowledge. Today, she's the Vice President and Deputy General Manager of the Space and Launch Division for Boeing, and it's my pleasure to pass the baton over to her.
Thanks, Mark. Kathy and Steve and Jill, thank you. As Mark said, it's really an exciting time here as we head to the launch pad, and we're really glad to be supporting our NASA customer on this really important mission. Others have already said it, but I really can't say enough about how well the team, including Boeing, NASA, and the subs have worked together to get through this time and ensure that we are returning to the pad safely and with all systems ready to go, as Mark described. The spacecraft looks great, it's performing great, and it's ready for its trip out to the VIF tomorrow. The team is also prepared, been rehearsing, they're ready to go, and we're looking forward to a successful mission on the 19th. Just to say a few words on the oxidizer isolation valve issue that we've been working through since our last attempt in August. There's been significant progress. We have been able to narrow down the root cause and put mitigations in place that I'll talk about a bit to ensure that we won't have a repeat of that concern. So we're confident that we've got that surrounded and have the right process in place going forward. When we first, if you recall, when we first experienced the issue in August, we immediately set up an integrated investigation team. So that was all team members, NASA-Boeing, and our subs involved to look at all possible causes with the goal of understanding the issue, mitigating it, and returning to the launch pad safely and as efficiently as possible. And I'm glad to be able to say that the team has accomplished this goal and we're ready to go. As you may recall, we followed a rigorous process to ensure that we understood the behavior. We went through a fault tree analysis. We looked at all potential causes, used facts and data to eliminate all of the potential causes until we were able to hone in on the root cause. And so this remains the cause that we talked about in about the October timeframe of this combination within the valve of the nitrogen tetroxide, or the NTO, ambient moisture, and the aluminum housing of the valve. And so you need all three of those aspects to come together in order for the first two, the NTO and the ambient moisture, to react to create nitric acid, which then reacts with the aluminum housing of the valve, causing corrosion products. And those corrosion products then result in preventing the valve motion, which is a very, very small motion, like 30 mils of motion, and just the presence of those corrosion products can hinder that progress. So that's the root cause that we've had. We've completed testing both on and off the vehicle. So we did return the vehicle to the factory. As you know, we did a lot of testing on service module 2 with the valves that had experienced this issue to understand the behavior and really hone in on what we were seeing. We've also been able to remove those valves since then and do disassembly of valves that were a valve that was stuck, a valve that was intermittent, and a valve that wasn't stuck. And what we saw within those valves were these corrosion products, as we've mentioned. So we were able to confirm the presence of these products in the way that I just said. We've also done off-vehicle material testing, and we've done off-vehicle valve testing with valves that had not been on the spacecraft at White Sands to confirm the generation of these corrosion products with these three constituents present. And in that testing, also, we have exposed those valves to the environmental conditions that the valves had seen, and also those environmental conditions that we expect to be seen on OFT2, and confirms that our mitigation methods are appropriate. So again, I'll talk a little bit about the mitigation that we put in place, and Mark has touched on it also. As I mentioned, in order to have this reaction, you need these three components: the NTO, the moisture, that's ambient moisture in the air, and the aluminum housing. Without those three components, you don't get the reaction. So without the moisture, if you can eliminate the moisture from the valves, you won't have this reaction and it won't lead to corrosion. So we've done a number of things for mitigation, including a dry purge of the valves. So the valves have compartments through which we've got GN2 purging the valves to prevent any moisture from getting into the valves. We've also sealed up a potential moisture path in the electrical connector to ensure that we don't get any ambient humidity through that path. So those two things will prevent the moisture from getting into the valve to start that reaction at all. And then in addition, we've loaded the NTO later. Mark mentioned that the vehicle is loaded, but we did do that later in the flow so that there's less time of exposure of the NTO. And we've added, operationally, we've added cycling of the valves every 2 to 5 days post-load until the time that we launch to ensure that the valves remain operational. So we've been doing that cycling. We've done that successfully. We'll continue to do that. The last cycle will be on the 17th, and then during the nominal countdown launch procedure on the 19th, we'll cycle the valves again. So with all of those items in place, we're confident that we understand the issue with the rigorous investigation that the team has undertaken, the testing that's been completed both on the vehicle and off the vehicle, and the operational controls and mitigations that we've put into place. So lots of credit to the team. There was a lot of work to really go through all of the details and ensure that we've got this nailed. And so lots of credit to the team working closely together. Again, we're proud to support our NASA customer in this major step forward, and we're looking forward to the rollout tomorrow and a successful launch on the 19th. So with that, I'll turn it back to Josh.
Thank you, Michelle. And we'll now turn for the question and answer portion. Our first question today will be from Jeff Faust at Space News.
Hey, good afternoon. A question probably for Michelle Parker. I don't know if I caught everything in terms of the mitigations, but are you doing anything to change the valves themselves, for example, reducing the amount of aluminum in the housing that would be susceptible to corrosion?
Yeah, thanks, Jeff. We have not redesigned the valve at this point. These are the same valves. We have added sealant around the electrical connector, which is the path in which the moisture ingress to the valve, the ambient moisture ingress to the valve. So we've made that change. And then external to the valves, we've put we've put compartments around the valve so that each of the valves can be purged with nitrogen to keep the moisture away from the valve.
And our next question is from Bill Harwood at CBS News.
Yeah, thank you very much. This is probably for Michelle too, I guess. I've always been wondering if there's something unique about the Starliner architecture that you had the problem there when, all rockets, use these propellants and have valves. And I'm just wondering what you might have learned that shed some light on why you guys got stuck with this corrosion issue. And I don't recall things like this on other vehicles in the past. Maybe a dumb question, but I just was curious what insights you might have. Thanks.
Yep, no problem. Well, I'll just point out that we did successfully use these valves on OFT1, so they were successfully used there and during our SM hot fire test. So we have successfully used the valves. We didn't learn anything specific about the valves other than what I mentioned, that we're sealing this ambient moisture path. There was a path that would allow, if there were humidity in the air, for that humidity to enter into the valve. So we have sealed that path. The migration of NTO through Teflon is a known phenomenon. That is known to occur. It has occurred in other valves. But Teflon is the most appropriate material to use in the presence of NTO. And I would say the one other learning that we've had is the duration of time that we loaded that the NTO was sitting in the vehicle. And so, as I mentioned, we have loaded as late as possible to ensure that we've got a successful launch.
Thanks.
And hey, Bill, these prop ISO valves, especially with NTO, that they're like the bane of our existence. So this is something, it is not a new phenomenon on the spacecraft side, but we're learning a lot about this as we're going through our spacecraft.
I would add, Kathy, I would say, from my experience in shuttle, we had problems with oxidizer corrosion, and not specifically in an isolation valve, but with thrusters, and we had to take some mitigations to eliminate moisture and forming iron nitrates and things that caused some valves to stick on the shuttle RCS system. So it's a long-term kind of issue across human spaceflight and other spaceflight, having corrosion in valves with oxidizer exposure to moisture and permeation of the vapor across the Teflon seals, which we know happens. So.
And we've done purge systems. We did the same purge systems, right? So it's to keep anything that's potentially open to the environment, keep that area dry. Same kind of mitigation.
And our next question is from Stephen Clark at Spaceflight Now.
Hi, thanks for doing this. You mentioned no changes, no hardware changes to the valve itself for this mission, just these mitigations. Going forward for future Starliner missions, are you looking at a different valve design? Any changes that you're considering or are currently in work that you plan to introduce somewhere down the line to further reduce the risk of this occurring in the future?
Stephen, maybe I'll take that one. And so we have a usable, as mentioned, we have a usable solution for OFT2. We don't expect to have any issues. As always, we'll look long term and see if there are improvements to be made. As somebody mentioned, the aluminum housing may be one piece of that. But right now, we're confident in the solution that we have going forward, and we'll continue to look at future missions.
And our next question is from Marcia Dunn, the Associated Press.
Yes, hi. One real quick question and one longer one. If everything goes well on time, more or less, when would be the earliest you might expect to fly your first crew? And also, for the Boeing reps, do you have this sense of trying to have to play catch-up here? I mean, I'm assuming it must be frustrating or difficult watching the competition launch crews right, left all the time, and you guys are still waiting to get up and get to the space station. How do you cope with that? How do you deal with it? Is it in your minds at all as you work forward to launch? Thanks.
This is Mark Nappy. I'll take the first part of that question. We have been working the next mission as well as getting ready for OFT2. We have a schedule that supports working throughout this year and then getting in a position where we could potentially be ready by the end of this year. We understand we are going to learn a lot from OFT2. That and many other variables will dictate where the final schedule falls with the launch of the CFT. But right now, we've got a target for the end of this year.
And I think with regard to this is Michelle, with regard to the second part of that question, our focus is really getting to the pad safely, getting through the mission safely, learning as much as we can, and being able to provide a great service to our NASA customer. And that's our focus right now. I think there are a lot of exciting things going on in space, and as space professionals, we're always excited about everything that goes on. We certainly want to be a part of that. We're looking forward to the successful mission, and that's our focus really, is getting to the successful mission and being able to deliver this capability to our customer.
I'll add to that.
Oh, hey, go ahead, Mark. Sorry.
Well, I was just going to add to that. I represent the workforce, and I talk to them frequently, and they're professionals. They understand what we're doing here. This is very difficult to build and develop and launch this type of vehicle. So they're very laser focused on doing this right, and that's really where their minds are. So we're going to do this the safest and with the best quality possible, and when we launch, we launch.
And Marcia, I'd say, this is about a team, right? And so I'm very grateful that Boeing is not, and Stitch is not taking any shortcuts. We're doing it, one step at a time, did extensive testing, made sure we took hardware off vehicles, went and did detailed failure investigation, made sure that we really understood this before routine vehicles up and bringing them forward into a launch campaign. And so that really showed to me a great deal of maturity and not being in a hurry. And obviously, we're also very grateful that SpaceX is giving us this opportunity to be able to have that time and fly. But these are the kinds of things you got to do when you do human space flight. And I think as a joint team with Boeing and SpaceX, we really, I've been very grateful to both providers operating in this manner and being able to provide this support.
Thank you.
And our next question is from Eric Berger at Ars Technica.
Hi, thanks very much for doing this. Just a quick follow-up on Marsha's question and a second one. These are probably for Kathy or Stitch. Mark mentioned that, they're targeting by the end of the year, but what do you think from NASA's perspective is kind of a minimum amount of time to analyze, data from this flight and clear Starliner? Is it 6 months? Is it less? I've heard it's 12 months. So just some clarification from NASA's perspective on that would be helpful. And then secondly, do you have all the approvals you need from the partners, including Russia, for Starliner to dock with the ISS? I recall this was kind of an issue with the first Dragon mission to ISS. Thanks.
I'll take the first question, and then I'll let Joel take the second question relative to the partnership and allowing OFT2 to dock. In terms of overall schedule for CFT, I think we'll just, as Kathy said, we're taking it one step at a time. Mark and his team are working to have the hardware ready for the CFT vehicle by the end of the calendar year. And then we'll sit down after the flight and review all the data from OFT2 over a number of months, see how the vehicle performed, lay out the schedule for the rest of the certification work, and then we'll select the launch date when the time is right to go fly CFT. Both flights are very important to us, OFT2 and CFT. I know my team's probably tired of hearing me say it, but I think the best path to CFT is a successful OFT2 flight, because really this is the time that the vehicle is put through its paces in the space environment for the complex rendezvous and docking sequence with the navigation sensors on Starliner. And really the only way to test that we've found is in the space environment, also the NASA docking system as well. And so these are big, important steps on the way to CFT. And Joe, I'll let you take the second question.
Hey, thanks, Steve. From an ISS standpoint, we had our stage ops readiness review last week, and everyone pulled go, including our international partners, all the international partners. As Kathy mentioned earlier, we will have the flight readiness review on May 11th, and so it'll be another opportunity where we'll engage management across the agency, as well as one more talk with our international partners, but we're not expecting anything other than a go at this time.
Our next question is from Peter King at CBS News Radio.
Great, thank you, and good afternoon. This is for Michelle or Mark, and assuming everything goes well and the data checks out, how many flights have you got booked for NASA, for the ISS, and for other clients, or how many do you envision once you're operational?
Hey, this is Mark. I'll start off and see if Michelle wants to add anything. Obviously, we've got the OFT2 mission coming up. We have CFT at the end of the year, and then we have 3 PCM missions that are on contract, post-certification missions, and then there'll be a follow-on after that for PCM 4, 5, and 6 that are not authorized today.
And our next question is from Irene Klotz at Aviation Week.
Hi, for Mark or Michelle, in the process of looking at the issues with the valves, did you find anything else that needed to be addressed on Starliner or any other Boeing programs? And for maybe Steve or Joel, could you just go through the differences between the NASA docking system and the Dragon? Thanks.
Hi, Irene, this is Michelle. I'll take the first one. From the outcome of the valve investigation, we did not find anything else on the vehicle or any other Boeing vehicles that would be sister issues to the valve issue. We've gone through our normal testing on spacecraft 2, worked through all of that testing, so no major additional findings on spacecraft 2. She's ready to go.
Let's see. I'll take the question on the NASA docking system. I would say fundamentally the Dragon docking system and the NASA docking system are very similar. SpaceX has designed their system to be optimized for the Dragon vehicle in terms of its mass and its performance and speed and velocity, closing rates and so forth to ISS. The NASA docking system is a little bit of a broader design, and it's designed for a range of masses. And so for this flight, obviously, it's optimized for Starliner. And then it can be used also for Orion. In fact, Orion is using a derivative of the NASA docking system that has a few changes for that vehicle's power architecture and then the space environment. So overall, they're similar systems, but the NASA dock system is tunable for a wider range of masses and conditions than that's used on Dragon.
And our next question is from David Curley, the Discovery Channel.
Thanks very much, Josh. Mark and Michelle, you mentioned you hope to learn a lot from the vehicle. I think after OFT-1, Boeing said, we learned a lot. Of course, you didn't approach dock and undock. What specifically are you hoping to learn? What are the areas of most interest in OFT-2? Thank you.
Yeah, thanks, David. So yes, we certainly learned a lot during OFT-1, and if you'll recall, we did get to orbit, and we did have actually a pretty beautiful, successful landing. So we've exercised, the ascent, and we've exercised the reentry, descent, and landing during OFT-1. So we learned, we did learn during that. The areas that, of course, the whole mission of it is of interest to us, and we will learn, but the areas that we are, most looking at, because we haven't exercised them yet, are certainly the docking with the station, so approach to the station, and the actual docking and time that we spend on the station, and then the undocking. So those areas that we haven't yet demonstrated will be of particular interest to us, although the entire mission, of course, we have criteria that we need to meet and demonstrations that we'll do, and the successful docking will kind of complete the test program that we've started during OFT-1.
Our next question is from Micah Maidenberg at the Wall Street Journal.
Hi, can you hear me? Mark or Michelle, I think. In terms of the new mitigations that you mentioned, just why weren't those incorporated from the start, of Starliner, and do you think they should have been? And then second, kind of bigger picture, given what you've learned after the valve process and the review following the 2019 flight, could you talk about any broader changes to how, Boeing designs or thinks about designing space vehicles? Thanks.
Okay, so the first part of that question, Mike, was why wasn't the mitigation put in place in the first place? We have successfully used these valves, right? These are the same valves that we used during SM Hotfire, pad abort test, as well as OFT-1, all successfully. So there was no reason to believe that we would have this issue. The valves did go through a qualification program. So, we are learning along the way the time of exposure, the ambient humidity, and what the valves, are susceptible to. So I would say, based on our experience and our use of the valves, we didn't anticipate that we would have this issue, so the mitigations weren't in place at that time. At this point, we're putting everything in place that we can to ensure that we are not having the constituents there that we need to create the corrosion products. So, and then the second part of the question about what we've learned from OFT-1 and 2, and perhaps any changes that we've made to the way we design spacecraft. Let's say, Boeing has been doing space for a long time, both on the unmanned satellite side as well as human space flight. It is an environment where we always learn a lot, and I expect that the industry as a whole will continue to learn as we do more and more in space. I think our big learning off of OFT-1, if you recall, was two issues, a software issue and a communications comm issue. So the software did certainly lead us to reevaluating the way we do software development and how we do testing, and that we've not only looked at Starliner from that perspective, but many of our other programs as well. So that's certainly a learning that's fed its way back into many of our space programs to ensure that we don't have that concern again. And then the comms was about the system integration and looking at the system as a whole and not just the piece parts. And that I think that is an area we're strong in and continue to learn and grow in those areas. So yeah, as always, we take the learnings that we have and we incorporate them across the board.
Our next question is from Ken Chang, The New York Times.
And going forward with reflying OFT and the additional delays because of valves, it seems like this is now a money-losing proposition for the company. And obviously you want to fulfill your obligations to your customer, NASA, but Boeing obviously also wants to do things that are profitable.
Ken, I'm sorry, the beginning of the question cut off. Would you mind repeating?
Yeah, I was wondering if you could talk a little bit about the business case for Starliner going forward, given that you've incurred the additional costs of reflying OFT and the additional delays. Is this still something that Boeing sees as how do you make money on this at this point?
Yeah, Ken, thanks for the question. As already mentioned, we're focused first and foremost on getting safely back to flight and meeting our commitments to NASA, to our customer, and being able to bring this capability to NASA. So that's our first focus. We have other prospects. We have Orbital Reef that we're a part of the team there to use Starliner for transportation to Orbital Reef, and expect that there will be additional opportunities in the future. The vehicle is able to dock with different vehicles, so I think that gives us something to build on, and we're committed to the program. But first and foremost, and today we're really focused on getting back to flight safely, getting through our certification missions through OFT and CFT, getting to certification, and looking at the service to NASA long term.
And this is Steve Stitch. From a NASA perspective, I work hand in hand with Mark and Michelle and the Boeing team, and they are certainly committed to doing everything they can to fly our missions successfully and safely, including OFT-2, the crewed flight test, and then the post-certification mission. So I see a commitment from them every day, their employees, their team, to do the proper analysis, to do the proper testing, do the things that we need to do to make sure that we're ready to go fly the missions. And so they put a priority on that and meeting the mission, and NASA certainly appreciates that.
As a reminder, if you would like to ask a question, please press *1 on your phone to enter the queue. And our next question is from Will Robinson-Smith at Spectrum News 13. And I'll check in again for Will Robinson-Smith at Spectrum News 13. All right, our next question will be from Ken Kramer at Space Up Close.
Hi, thank you for doing this. Can Boeing people talk a little bit more about the source of the ambient moisture, what you think it is, exactly a little bit more about the mitigation, and have you completely excluded the external rain that we had at that time? And if you could quantify the amount of the moisture that caused this corrosion. Thank you.
Hey, yes, Ken. So again, we've done extensive testing on this. So we really do believe that the moisture is the ambient moisture in the air, just caused by humidity, both in the factory, potentially at the launch pad, but not the rain event, just ambient moisture in general. So again, the mitigation of purging the valve with the nitrogen will remove any ability for moisture to get into the valve to create the corrosion products. We've also looked at the environment both in the factory and at the pad. So we've got these compartmental nitrogen purges, as well as when we get to the pad and have to come off the individual purges, the ULA provides a vehicle level purge as well to ensure that that environment is drying up, doesn't have that ambient moisture in an area that will get into the valve. So again, that's where we've shown it through tests that the ambient moisture in the air just through humidity can make its way into the unsealed or unpurged valve in order to create the corrosion products.
And the amount of moisture?
Let me add to what Michelle said, and then perhaps you can have a follow-up. So in order to verify this theory, right, that it is moisture coming out of the atmosphere, we did testing at the NASA White Sands test facility with these similar oxidation valves. And so what we did is we had a test chamber and a valve that didn't have a sealed connector, and we exposed it to the kind of environment that we would have seen in the C3PF where the vehicle is processed, and also in the vertical integration facility. And we exposed it for a number of days, weeks, and time frame, let that moisture seep into the valve. What happens is this oxidizer vapor sort of draws moisture in. And so what we did is we took those valves and we sent them to the Marshall Space Flight Center, and Marshall has an incredible materials lab facility. Disassembled the valves, and they looked at the corrosion products, and they were very much indeed the same as what we saw on the service module 2 when we removed 3 valves and sent them to Marshall. So we know that it's this moisture being pulled in through the seal that wasn't well sealed, or the connector that wasn't well sealed, and that materials analysis confirmed that. So as Michelle said, what we've done this time, and NASA's been a part of this investigation, we've sealed the connector around these oxidizer isolation valves to eliminate moisture coming in to the area where that vapor could be near the aluminum housing. And then we have a purge, a dry nitrogen purge, that keeps moisture out. And so it really is, there's two barriers or two preventative measures for letting the moisture go into the valve. And I'll see if you have a follow-up.
Just the amount of moisture that you found.
I think it's so let me try to back up a little bit. So when the moisture comes in and meets with the oxidizer vapor, it forms nitric acid, and so that nitric acid then will corrode on the aluminum. So you don't really see moisture per se in the valve. What you see is a white precipitate material that's an aluminum nitrate that's formed by the nitric acid eroding part of the surface of the aluminum housing. And so you don't really see moisture, so it's really hard to quantify how much moisture went into the valve. We do know that as that vapor permeated, that there's a reaction that happens. So vapor comes across a Teflon seal, then you end up ingesting moisture, that forms the nitric acid, and as long as there's aluminum present for that nitric acid to react on, it continues to build more precipitate. So not precipitation, but the precipitate, the iron nitrate or the aluminum nitrate precipitate.
And the source is just, I mean, if you've been in Florida in July, just imagine being outside. I mean, it's just the ambient humidity of, I mean, that just shows you, you know, this is kind of an insidious thing, because it's just, you have a vehicle on the pad, right, and it's that ambient, and then this very tortuous path. But we found out that those two things, and just being out there, Florida in July it's humid, right? And so it shows how, like Michelle said, this is hard. You know, you have this tortuous path and this environment that we've seen in some cases causes this reaction with the NTO. And so we learned something with it being out there in July.
And our next question is from Mike Wall at space.com.
Thank you for doing this. Just a quick question about the cargo. Could you go into a little detail about what's going up on OFT2 and what's going to come back down again with it?
Well, this is Joel. I'll take that one. The majority of the cargo going up is going to be food, and so about a little over 450, 460 pounds of the 500 is mostly food, and then coming back, we'll be bringing home some of the NORS tanks, the nitrogen oxygen recharge tanks that we have on board. They are used, and so we'll return them to the ground, refurb them, and then fly those again. And so that's the big highlights. We're also flying up some small vehicle hardware, some spacewalk supply hardware as well.
Great, thank you.
Our next question is from Will Robinson Smith at Spectrum News 13.
Hey there. Thanks for taking my question. Apologies for having to step away a moment ago. Wanted to ask, with the work that was being done to evaluate the valve issue and get ready for OFT2, I know in the original process and throughout this with OFT that the crew for CFT has been involved. Can you talk a little bit about, I guess, question for either Michelle or Mark, what working with the CFT crew has been like in preparation for first OFT2 and then successively CFT hopefully later this year? Thanks.
Sure, this is Mark. I'll take that. First of all, it's been a pleasure to work with the crew. They've been very open with us on areas that they would like to see more information on. Obviously, we're getting them accustomed to the crew module and the use of our capsule, and so everything that we've been doing has been done in lockstep with them, so that we both understand. Number one, they understand what we're doing, and we understand what their needs are and anything that they'd like to see better explained or even possibly changed. So it's been a very good process of working with the crew, and we'll continue to do that. We have a big test coming at the end of July where we do a very structured walk through the vehicle and testing of the vehicle with the crew, and we're working towards that.
And I would just add, this is Steve Stitch. I mean, the crew's been involved in many things getting ready for their flight as well. Obviously training on the vehicle, the suits and the seat interface, display testing, the displays that will be used. They've been following along with all the software testing, including the mission rehearsal that Boeing completed recently for the OFT2 flight. So they've been following along with not only the valve investigation, but many things on the path to the crewed flight test.
Our next question is from Paul Brankman at Aerospace America.
Hi, yeah, thanks for taking my question. I guess I would just like to ask Kathy if she could address whether NASA will be looking at its many different reviews of Starliner design and construction to sort of ask the question, why was this not identified as an issue in those reviews? Because Florida humidity is a pretty well-known factor, and NASA has been launching from Florida for decades. So is there something that can be done going forward to make sure that new spacecraft design are reviewed and tested for this issue? Thanks.
Yeah, I think that's a great question, and honestly, one that we've been really looking at for the last 8 months, right? Where the team went back, honestly, and went through all the subsystem reviews and other pieces, and we're a pretty aggressive lessons learned team. I mean, we really believe in when this happens, going back and going, what did we learn out of this, and how does that help us going forward? And so there's a couple things. One is, like I said, this is a very tortuous path. I think the amount of wicking and that wicking phenomena that Steve looked at. I mean, when we looked at this and we looked at the different pieces, I think, you know, we learned something about how these valves work. Like Michelle said, you know, they'd been through many tests, qualification, everything else, and we still learned something new. So we're taking that learning back. We actually, the engineering teams across the agency took that, and Ralph Rowe and his team went and looked at all the different kind of valve designs, the other things to go say, you know, are we susceptible anywhere else? And this is a great example. We really appreciate, honestly, Boeing and, you know, sharing with us, and because then we're able to take this learning, and I feel like from a NASA team perspective, one of the greatest things about us being able to work on these multiple spacecraft is that we can always learn from these new exercises and apply that to our future exploration products. And so, yeah, this was a susceptibility, or we didn't understand that you would have that torturous migration, but this is teaching us that you can't assume that those connector paths and those other things are protecting you from this phenomena. This is a pretty aggressive phenomena, and so we will definitely take that learning in our future programs. But thank you for the question. Great question.
And our next question is from Assam at AFP.
All right, hi, sorry I was on mute. Good luck for everything, and hope it goes well. My question is, though, you know, is there a mechanism for, you know, if the program continues to fail, is there a mechanism to cut the losses and cancel the contract?
Yeah, I would say we have no intent on the NASA side of doing that. We've been a partner with Boeing all the way through since the beginning of the Commercial Crew Program, the award of the TCAP contract, all the way through the investigation. We have confidence in the vehicle we're about to go fly, and confident that it'll perform well in the flight environment. I suspect we will learn, like we do on every test flight, and even some of our recent operational missions to the space station, we learn every flight. And so our intent is to have 2 certified space transportation systems and go fly the crewed flight test when we're ready after OFT2, and we look at all the data, and then move on to the post-certification missions that Mark alluded to on the contract. So.
Thank you.
We have time for maybe 1 or 2 more follow-ups, and it looks like I'll go to Irene Klotz with Aviation Week.
Thanks, Josh. I just was wondering if there's going to be live video available from Starliner prior to docking, and also with the delays in the mission, if you're expecting to get through all 6 PCM flights before ULA phases out Atlas V, or will some of those be transitioned over to Vulcan?
So we do have a video system that has been added to the vehicle. For this mission, we'll have a live feed of docking only, and then the rest of it will be information that can be downloaded. And I think the second part of your question was on Atlases. Can you repeat that, please?
Yeah, just with the delays in the post-certification missions, if you're still expecting to get through all 6 on Atlas V before ULA phases out that booster.
Yes, we've already secured those Atlas vehicles for our PCM missions, so we are in good shape and don't have a threat of running out.
Thanks.
And our last question is from Stephen Clark at Spaceflight Now.
Hi, thanks for taking the second question. Just wanted to clarify something, and I apologize if I missed it. The GN2 purge into the service module propulsion system, when does that actually terminate before launch? Are you getting a purge while you're, after rollout from the VIF out at the pad, and when does that terminate? When does that purge end? And also wanted to maybe ask Kathy Leaders if she has any update on the Space Launch System troubleshooting in the VAB since the vehicle rolled back. Any luck in finding that hydrogen leak yet? Thanks.
Maybe the first, Stephen, the first part of that question, once we get onto the launch pad, that is a full up vehicle purge, right? A rocket purge with a nitrogen that Atlas, that ULA provides, and that will be sufficient for that part of the launch processing.
Yeah, and Jim Free and the team will be doing a press conference on Friday, but I think troubleshooting is going really well, and they've identified some conductor fittings, and I'll let you save those questions for him on Friday. You guys can start getting your questions ready now. Thanks.
All right, and that's going to wrap up our question and answer portion, and I will give it back to Kathy Leaders for some closing comments.
Yeah, I think I just wanted to reiterate what I said before about how proud I am of both the Commercial Crew Program, the ISS program, Boeing, and the whole team kind of making sure that we're getting ready again to do this right. Obviously looking at everything across the board. The team last year, really took the vehicle back to the C3PF, wanted to make sure that they pulled the hardware, investigated it, made sure that they understood why we'd had the problems we had out in the pad before, and then getting ready for this mission now. And the team wasn't in a hurry. The team worked through, laid out a plan, got through the testing, worked through the reviews, and then stepped into and held their dates to be able to hit this launch window. Very, very proud of them for doing that. And then again, wanted to underscore that, because of the partnership we've had, because of the fact that we had two providers, we're able to continue flying and enabling them to continue, SpaceX to continue to provide our crews to the International Space Station. It is a real partnership, and we'll continue to do that going forward. Thank you.
And that's going to wrap things up for us here. NASA's Boeing Orbital Flight Test 2 is targeting a launch to the International Space Station on Thursday, May 19. We'll have more on this important mission coming up as we track our reviews. You can learn more about the mission on nasa.gov/commercial crew. Have a good day.
Thank you for your participation in today's conference. All participants may disconnect at this time.